How much energy would a warp drive need? Let's just say, if you've got a spare Jupiter lying around, it could be a start. These are 10 challenges to building a warp drive, and this is number 4, the energy problem. Now, to compress space-time in front of your ship and then expand it behind it, you need enormous amounts of energy. Alcubierre's original 1994 calculation found that for about a 100-meter bubble, the energy requirement was on the order of the total mass energy of the universe. But that was just an estimate. Using some more realistic parameters, later estimates found that for a bubble around a ship the size of the Enterprise, which would be about 300-meter long bubble, you would need energy equivalent somewhere between Jupiter's mass and several times the Sun's mass. Still a lot. Jupiter's mass is about 2 by 10 to the 27 kilograms. That's 2 octillion kilograms. More mass than all the planets in the solar system combined. And you would need to convert that entire mass into pure energy using E equals mc squared, which would give you roughly 10 to the 44 joules. Now, to put that into perspective, the Sun outputs about 10 to the 26 joules per second. Jupiter's mass energy is equivalent to the Sun's entire output for 3 billion years. The total energy output of our entire civilization in all of human history is only about 10 to the 21 joules. So we'd need to collect our civilization's energy production for 10 billion times the age of the universe to match Jupiter's mass energy. That's just the energy, it's so much. I'm really struggling to give you a good idea of the quantities here, guys. But we're not going to worry about this too much, because when we're talking about amounts of energy, it's one thing, because it's just the energy requirement of what you need. The thing is, you also need the energy to be in a very specific form. But we'll get to that. The energy scale alone makes warp drive impossible with anything resembling current or foreseeable technology. Because we're not talking here about advanced engineering. We're talking about energy requirements that exceed what entire solar systems can produce. But in 2012, NASA announced that they'd figured out how to reduce it. And that's for the next episode. Stay nerdy.